In example 9, we find the third order Taylor approximation to the function we looked at in examples 6 and 8. That is, y equals the cube root of x about the point x equals 1. It's a third order approximation. Do we have that n is equal to 3? A Taylor polynomial then is that f of x, the function, is approximately equal to the function evaluated at a plus 1 on 1 factorial 1 times the first derivative evaluated at a times x minus a. Thus far it was the linear approximation. If we add one more term we get the quadratic approximation. Well, that's 1 on 2 factorial times the second derivative evaluated at a times x minus a squared. And for the third order polynomial we add one more term, 1 on 3 factorial times the third derivative of our function evaluated at a times x minus a cubed. And that's for x close to a. Our first step then is to find values for f of a, f prime a, the second derivative evaluated at a, and the third derivative evaluated at a. We'll first find the derivatives, and then we'll evaluate them at a. The function f of x is equal to x to the 1/3, the cube root of x. First derivative, x prime a, will equal 1/3 x to the minus 2/3. The second derivative will be minus 2 on 9 times x to the minus 5 on 3. And the third derivative will be 10 on 27 times x to the minus 8 on 3. We want to evaluate the function and those derivatives for a equals 1. The value of the function at 1 is equal to, well, 1 to the 1/3 is equal to 1. The first derivative evaluated at 1 will be 1/3, 1 to the minus 2/3. That's equal to 1/3. The second derivative, f prime prime, evaluated at 1, will equal minus 2 on 9 times 1 to the minus 5 on 3, minus 2 on 9, and finally the third derivative is equal to plus 10 on 27. We substitute those values into our third order polynomial. We have the general form of the third order polynomial there. We'll substitute in for the values we just found. So our function is approximately equal to f of a we found to be 1 plus 1 on 1 factorial is just 1. F prime a was 1/3 times x minus 1 plus 1 on 2 factorial, so that's 1 on 2, times the second derivative, what was minus 2 on 9, times x minus 1 squared, plus 1 on 3 factorial, so that's 1 on 3 by 2 by 1, so that's 1 on 6, times the third derivative, 10 on 27, times x minus 1, all cubed. We can simplify that. F of x is approximately equal to 1 plus 1/3 times x minus 1 minus 1 on 9 times x minus 1 squared plus 5 on 81 times x minus 1 cubed. So here we have our third order Taylor series for the cube root of x about 1. What we can do now is to find the cube root of numbers close to 1. As we did in examples 6 and 8, we'll find the cube root of 1.03. What we do is to substitute 1.03 where we see x. So that will be 1 plus 1/3 times, well, 1.03 minus 1, it'll be 0.03, minus 1/9, 1.03 minus 1, 0.03, this time squared, plus 5 on 81 times 0.03 cubed. We do that calculation and we find this time the approximate value for the cube root of 1.03 is 1.00990 0, 1, 7.